Hey guys, welcome back to a lecture series on inverse Z transform. For similar videos guys, do check in my I button. You will get the complete playlist, or you can check in my description box down here. You will get the complete playlist based on the Z transform, Fourier transform, Fourier sine cosine transform, their inverse transform with the linear differential equation with constant coefficient, that one also, and inverse Z transform. You will get entire playlist. So if you're interested to see similar video, do check it out. Okay, so in my today's video I'm gonna explain to you all Z inverse transform for this sequence. Okay, this sequence. So this one is very much important for your coming in same exam guys. Be careful about these type of questions. Okay, so without further ado, let's get dive into our today's lecture. I'm gonna explain to you all first of all the example and which method is suitable here for solving this example. Okay, yes. Now we can see that 1 upon a minus b plus into b minus c, similar type of the Fourier transform or similar type of the Z transform or integral we can solve using partial fraction method. Okay, it can be solved easily by partial fraction method. Directly you cannot apply over here, Z inverse transform for solving this Z inverse transform. Okay, yes, for solving this Z inverse transform you have to apply partial fraction method. Okay, we need a standard form. Yes, let's get to solve this example here. Remember guys, you have to solve this part over here, put it here and find out the Z inverse. Okay, yes, so I'm going to simplify Z minus 1 by 2 into Z minus 1 by 3. Okay, 1 upon Z minus 1 by 2, Z minus 1 by 3. I'm going to solve this part over here. Okay, now watch very carefully, because this one is very much important. Okay, so see that I explained in my last lecture for applying partial fraction, with some formulas. Okay, yes, you can check this formula from there. Okay, so we know that whenever we have any polynomial, okay, let me write the formula. Okay, let me write the formula over here so that you can understand. Okay, I'm writing formula that I'm going to apply over here. Okay, yes, so whenever we have any polynomial cx plus d, you can take anything, it is nothing matter. Okay, a upon or some constant upon or anything. Okay, divided by, but make sure that the denominator which you are going to write x minus a, x minus b, it has a power 1 over here. Okay, this need to be a linear. Okay, in terms of polynomial. Okay, x and a, so it has to be a power 1. So we write this one as a upon x minus a plus b upon x minus b. Okay, this one is actually x minus b over here. Okay, yes, this one is actually the form of a partial fraction, expanding form of a partial fraction. Okay, now see that some polynomial constant, it is also polynomial. Okay, so we consider one as a constant polynomial. Okay, so similar like this, upon denominator both are having power 1, linear polynomial. Okay, so I am going to write this one in this form. Okay, so a upon x minus a, that means z minus 1 by 2, z minus 1 by 2 plus a upon z minus 1 by 2 plus b upon z minus 1 by 3, z minus 1 by 3. Okay, I hope you all have understood how I have written this one. You have to compare this one with this, so automatically this side you will get it here. Okay, yes, now later on part is way easier guys. Okay, later on part, I'm telling you guys, partial fraction method, it is one of the easy method in entire mathematics. Don't have anything. Okay, yes, so I hope you all have understood the part which I have taken right now. Okay, yes, need to go for solving further, so it is way easier. Multiply, cross multiplication, do it here. Okay, so I'm going to write 1 upon z minus 1 by 2 z minus 1 by 3. Okay, which is equal to, go for the cross multiplication, z minus 1 by 2 into a, z minus 1 by 2 into a plus z minus 1 by 3. Okay, z minus 1 by 3, z minus 1 by 3 into a plus z minus 1 by 2, z minus 1 by 2 into b. okay, this into this, and completely divided by, now see that this multiplied by this plus this multiplied by this divided by this multiplied by this, okay. So z minus 1 by 2 multiplied by z minus 1 by 3, okay. Yes, you can see that how I have written. I hope you all have understood this second step. It is very important, guys. How can we write this step? Now see that this one is the denominator, same over here. This one it is also same here, or you can take it here and cancel both of them. We left here with the value 1, which is equal to a into z minus 1 by 3, okay, plus b into z minus 1 by 2. Okay, this one is the next step we left here. I hope you all have understood. This one is the entire part, guys. Don't have anything, just easily you can find out the answer. Actually this is that you are finding value for this, means you are finding value for this, okay, this entire term. But in this case we have a and b, which is an unknown constant that we don't want in our equation because it is not the part of example. These are the a and b we consider by ourselves, so we have to take a and b out from this equation. So in order to take a, b out from this equation, we have to consider the value for z. We have to consider the value for z in a such a way that whether a goes to 0 or whether b goes to 0, okay. Yes, so can I select, if, let me select the value, okay. Now you can select anything randomly, it is completely up to you, okay. Yes, so if I select z, which is equal to 1 by 3, okay, be careful guys, you need to understand, this is very important, okay. If I consider z as a 1 by 3, okay, here in this equation, okay, so we easily can omit a and we can find out the value for b, okay. Yes, and next time we replace z as 1 by 2, okay. Yes, let's go for replacement. 1 which is equal to a into z as 1 by 3, so 1 by 3 minus 1 by 3 plus b into 1 by 3 minus 1 by 2. Okay, what I have done, I replace z as 1 by 3 over here and over here, okay. So now see that 1 by 3 minus 1 by 3, it entire goes to 0, into a it goes to 0, okay. So I'm going to write 1 which is equal to b, 1 by 3 minus 1 by 2, okay. So what we do, go for the cross multiplication, so keep b as it is over here. So 1 by 3 minus 1 by 2, 2 ones are 2, minus 3 ones are 3, 2 minus 3, 2 minus 3 which is a 2 minus 3, okay, 2 ones are 2, minus 3 divided by 3 to the 6, okay. Yes, so what is 2 minus 3 which is a minus 1, minus 1 by 6, okay, take it here, we write b which is equal to minus 1 by 6, if you take it out here, so it is get the minus 6 only, okay. It is very easier guys, how I have written, let me explain again if you are confused, okay. So 1 which is equal to b into minus 1 divided by 6, okay, take that 6 here, it goes to the multiplicand, then take that negative also here, so I got the b as a 6 here, okay. So I'm going to replace b as a 6 over here, okay, b as a minus 6 over here. Similarly you have to find out the value for a, okay. Yes, so how can we find the value for a? When b goes to 0, then only we can find out the value for a, okay. Yes, or you can replace this b value over here, but it is quite confusing or difficult for finding, okay. So I'll suggest you all, don't go for the replacement of a b, instead of make that b 0, okay. So what I can do, that b goes to 0, if z is 1 by 2, then obviously b is 0, okay. So next step I consider, if z which is equal to 1 by 2, okay, replace z 1 by 2 over here, okay. So we write 1 which is equal to a into z is 1 by 2, okay, 1 by 2 minus 1 by 3, okay, 1 by 2 minus 1 by 3 plus b into 1 by 2 minus 1 by 2 plus b into 1 by 2 minus 1 by 2. 1 by 2 minus 1 by 2 is 0, so b into 0 it goes to 0, so 1 by 2 minus 1 by 3 into a which is equal to 1, okay, a which 1 is equal to a into, go for the cross multiplication, 3 ones are 3 minus 2, okay, 3 minus 2 divided by 2 3 is 6. What I have done, plus b into 1 by 2 minus 1 by 2, it is a b into 0 over here, okay. That means obviously b into 0 means entire step goes to 0 over here, okay. Yes, Yes. Now see that we have to solve this one. 3 minus 2. 3 minus 2, which is a 1. 1 upon 6. 6 take it here. So we got the A as a 6 over here. Okay. Yes. I got the B as a minus 6, A as a 6 over here. Okay. Replace B and A. Replace this B and A in our equation. In our equation here. Okay. So we will get the equation as a 6 into, okay, z minus 1 by 3, okay, 6 into z minus 1 by 3 plus 6 into z minus 1 by 2, or you can replace over here also, not any issue. Okay, you can replace here. So I'm going to replace over here. See that how I'm going to write this one. Okay, so B is a minus 6, this one replace minus 6 over here, and this one A is a 6, this one replace 6 over here. Okay, so actually z upon 1 minus z minus 1 by 2 into z minus 1 by 3, this value can be written as 6 upon z minus 1 by 2 and minus 6 upon z minus 1 by 3. Okay, yes. So let me write it to the next step. Okay, I'm taking this one into the next page now. I hope you all have understood, guys. This way is here, don't have anything. Yes. So I'm going to write a sequence f of k or f of z. Sequence z transform of f of k or f of z. We can write, okay. So we can write this one as a actually we taken this one as a upon z minus 1 by 2 plus b upon z minus 1 by 3. Okay, that means 6 upon z minus 1 by 2. Okay, 6 upon z minus 1 by 2 plus minus 6 upon z minus 1 by 3, minus 6 upon z minus 1 by 3. Okay, this one is the part we found it here. Okay, yes. So this one is actually a sequence. This one is actually a sequence. I found it here. Okay, yes. And we have some condition over here. Okay, mod z smaller than mod a. Okay, yes. Let's go for finding its inverse transform. We want the inverse transform now. We are working for the inverse transform, guys. Okay, so we get the z inverse of f of z as z inverse of under curly braces. Okay, z inverse of under curly braces 6 upon z minus 1 by 2 plus minus 6 upon z minus 1 by 3, curly brace complete. Okay, yes. Now see that that 6 is a constant over here. That take that 6 outside, as we have done in our z transform, that linearity property, that we can expand z transform with addition, subtraction, or with respect to some sign. Okay, similarly we have to do it over here. Okay, yes, take that 6 outside of inverse z transform and apply inverse z transform to this one first and later on this one here. Okay, yes, take 6 outside. Okay, how I'm going to write this one then? 6 z inverse transform of 1 upon z minus 1 by 2. Okay, yes, complete this bracket. Then take that negative 6 outside over here. Negative 6 z inverse transform of 1 upon z minus 1 by 3. 1 upon z minus 1 by 3. Okay, this is the way I have written z transform. Okay, yes. Actually z transform of a raised to k now we write z upon z minus say. Okay, and for that we need to have a condition. So we are going to replace the value over here. Okay, so here I have added 2 formulas that we learned in our last lecture. You can see these 2 formulas. We are going to apply these ones here. Okay, that we learned from the z transform also. Okay, yes. So we can see that we have given interval in our example modulus of z. Okay, which is the bigger than 1 by 3 and smaller than 1 by 2. Okay, so we have the interval for mod z. It is bigger than 1 by 3 and smaller than 1 by 2. That means we write this interval as 1 by 3. It is smaller than mod z, and mod z it is smaller than 1 by 2. Okay, So I have written this into the two form. Okay, yes. So I'm going to take this one over here in our example. Okay, we want 1 by 3 bigger than mod z. Okay, smaller than mod z. So we can see that z minus 1 by 3. So if I take here z as a 1 by 3 more or smaller than 1 by 3, so it can be applicable over here. Okay, so see that, compare this value with this one. Okay, yes. So we write this one 1 by 3 smaller than mod z over here. Okay, for this one. Okay, and here I'm going to write mod z bigger than smaller than 1 by 2. Okay, that means we want the value for z here smaller than 1 by 2, and it is the mod z here bigger than 1 by 2 using our given part. Okay, this one is given in our example. Okay, this one is given in our example, that I apply these two values over here for this inverse z transform. Now see that we have mod z bigger than mod a. Okay, so mod z bigger than mod a, it is applicable over here. Okay, it is applicable over here. So mod z, it is what we have, mod z is bigger, but it is mod z is smaller. So mod z, it is bigger over here. So you can apply this property to this one, and mod z is smaller than some mod a. Okay, so we take this property over here. Okay, for this one. So apply this property to this z inverse transform. Let me write this property here with a solution 6, as it is here constants. Okay, z inverse of a z minus 1 by 2 when mod z smaller than some value, mod z smaller than some constant, we write minus a raised to k minus 1. Okay, so we write minus a raised to k minus 1. What is the value for a? Which is 1 by 2. Okay, so minus 1 by 2 raised to k minus 1. Okay, k minus 1 keep as it is here. Okay, minus 1 by 2 raised to k minus 1 I written over here. Okay, yes. So minus next part, I solve this z inverse transform over here. Minus 6 keep as it is over here. Z inverse of 1 upon z minus 1 by 3. Okay, 1 upon z minus 1 by 3. We write a z inverse of 1 upon z minus 1 by 3. So what is the z minus 1 by 3? It is 1 by 3. So we write minus 1 by 3 raised to k minus 1. Okay, minus 1 by 3. Okay, we write minus 1 by 3. So see here guys, for this value z minus 1 by 3 mod a bigger smaller than mod z. So we can see that which we are going to apply, mod a is smaller than mod z. Okay, mod z it is bigger here. So with that we are going to apply this formula over here. So a raised to k minus 1. So what is the 1 by 3 raised to k minus 1? That means this one goes to the plus here. Okay, so 1 by 3 raised to, we write, it's like a bracket. It's not a sequence. You can write this one the form of bracket also, not an issue. Okay, k minus 1. Okay, yes, and we have k greater equal 0. Okay, so this one is the entire inverse transform. Okay, z inverse transform for our sequence. Okay, and sequence we have z inverse of 1 upon z minus 1 by 2 into z minus 1 by 3. Okay, so for that I return inverse z transform as a 6 into minus 1 by 2 raised to k minus 1 minus 6 into 1 by 3 raised to k minus 1. Okay, so this one is the entire z transform for the sequence. Okay, it is way easier guys, not a difficult. Okay, first of all you need to apply partial fraction method in order to resolve our given sequence. Okay, form z, and then thereafter apply inverse transform by using linearity and some another properties. Okay, yes. So I want you all to solve one more example. Take this example for your homework guys. Okay, I want you to solve this one. Do it for your homework. Similar like above example is this one. Okay, yes. So I want a z inverse of 1 upon z minus 5. Okay, 1 upon z minus 5 into z minus 3. Okay, so you take this example guys for finding the, and interval you also consider modulus of z smaller than 2. Okay, consider this interval. Okay, mod z less than 2. and find out the Z inverse transform. Okay, yes. So for that, first of all, apply partial fraction method, that you are going to write a upon Z minus 5 plus b upon Z minus 3. Okay, yes, put Z which is equal to 5, put Z which is equal to 3. Okay, so you can omit a and b. Okay, find out the form of a simplified form of this f of z, and then after that apply inverse z transform for the sequence by using linearity property, and use some results. Okay, use some results from the last page I given to you all. Okay, in my last lecture I explained. Okay, that is here for our today's lecture. I hope you all have understood, guys. Keep this one for your understanding. Okay, keep this one for your homework example. Okay, I hope you all have understood everything. Even after, if you found anything difficult, guys, let me know in my comment section. Okay, I will come up with a similar videos. So do this example for your homework. So thank you everyone. Thank you for my today's lecture.